So in lesson 101, I mentioned adding like terms together. So we're going to do a little bit more of that. So let's look at these two terms. I have 4xy plus 6yx. So we need to decide if these are like terms or not. So in order for them to be like terms, they have to have exactly the same variables with exactly the same exponents in each. So we don't care about the coefficients at this point. What we care about is only the variables, because we know that this is a whole number times x times y for this term, and this is a whole number, we don't care that it's 6, times y times x. We know that multiplication allows us, the commutative property of multiplication allows us to rearrange factors in any order we want, so that because they're going to give us the same answer. So that allows us to rearrange these until they match, or to see if they match. So let's see if we can do that. We disregard the coefficient because the whole number can be anything, or the coefficient can be anything. That's what we would perform this operation with. So we disregard it for the time being. We just ignore it. And we look at what variables we have. So we have an x times a y in this term. And in this term, we have a y times a x, which is the same thing as an x times a y. So when looking at these variables only, we see that they match. So that tells us that we can combine these terms together, because the variables that the whole number or the coefficient is going to be multiplied against are the same. So the relationship between these two numbers are exactly the same. It's like making sure that the denominator is the same. When you match your variables together, it's just exactly like matching the denominators. Only this time you're multiplying instead of dividing. So that means we can combine the coefficients, and we have 10 times x times y. So let's look at a practice problem. So in this practice problem, we have to evaluate and see if these coefficients and variables will work together, if there's a relationship between the two of them. And to do that, we just need to match the variables that go with each coefficient. And if they all are identical, then we can add the coefficients together. So let's look at the first one. The first one, the variables are x times y squared. So let's see if we can get that from the other ones. So in this second term, our variables, we have an x and we have a y squared. So these two are the same. We can combine them. What about this last one? Well, we have an x by itself, and then we have times y times y. Well, we know that when we have y to the 1 times y to the 1, we add those together. So that'd be y plus 1 plus 1 for the coefficient, which would give us a y squared. So this one matches as well. So that means that we can add the 2 and the 3 and the 7 together, and that gives us 12 with variables x, y squared. And that would be our answer. So let's look at another practice problem. All right, in practice problem number 2, we have a 4x plus 3 plus 6x plus 4 plus 2xy plus 3yx plus 2. So here's a little trick that I've picked up that might help. It's called stacking. So what I do is I look at each term and then I put it in a position with other terms that are like it so that I can add them vertically. So it looks like this. If I have a 4x, I write the 4x because that's the first term. So we haven't even checked any of the others to see if there's anything like it. So we know it goes over here in a column by itself. So that's the first term. All right, and that's a positive 4 because when we don't write the symbol in front of it, it's a positive. Now we have a positive 3, and there are no variables, so it needs to go by itself right here, right? So there's that one. So now I have a positive 6x. Well, this has an x, so these are like terms. So I should be able to add the 6 to the 4x, just like that. All right, now I have another number by itself, a positive 4. So I'm going to put positive 4 with this positive 3. Cross it out. Now I have a 2xy. Well, I have an x, but I don't have one with an xy. So this one is unique. So I'm going to start another column for it. 2xy. So there's that one. So now let's look at the next one. I have a 3yx. Well, it's an x and a y. It's just rearranged. And we know that the commutative property multiplication says we can put that in any order we want, and it's the same answer. So we're going to just put it in the same order and put it underneath the 2xy because it's the same variables, xy, xy. So that one's done. So now we have one term left, and that's a positive 2 with no variables. So I can write that over here with the other whole numbers without variables, or constants is what we like to call them. And so that's all of the terms that we had. Now all I have to do is draw a line underneath and then add the terms together. Let's start on the right. That might be better. So positive 2, positive 3 xy's. So I put my xy, and that's going to be a positive 5. All right, so I have 3 plus 4, that's 7, plus 2, that's 9, so I have a positive 9. So now I have a 4 plus 6x, that's going to be a 10x. So my answer is 10x plus 9 plus 5xy. Because I used the stacking method, it was a lot easier to organize all of these terms by sorting them into the ones that go together. So that's a technique that might be helpful for you as you go through finding like terms, especially if you have these big, long expressions that you need to combine. Try stacking and see if it simplifies it for you. All right, let's look and see if we have another one that we can do so that we can get some more practice. And we do. We have one last problem. So let's try it. All right, so here we have some more terms in this expression, and I'm going to use the stacking method again. I think it really helps me to organize the terms and sort them out. So we have a 4 constant by itself, so that's a positive 4. So I'm just going to write that here, positive 4. I'll cross it off my list. And I have a positive 3x squared. So I'm going to put it over here in this column, positive 3x squared. And I know that's just x times x, which is helpful and handy because I see an x times an x here. So I know that's x1 times x1. When I add those two together, I get 2x squared, right? That's what that becomes, is an x squared. So I'm going to put plus 2x squared underneath this one, and I can cross out the whole thing. Now I have a positive 4x. Well, I have an x squared, but I don't have an x to the 1, so I'm going to make another column just for that. So that one's done. Now I have a positive 7, a constant all by itself, so I'm going to put it over here with my constant of 4, and that one's taken care of. And now I have a positive 3x by itself. We'll put it with this x term, and now I'm going to draw a line underneath all of these and add them together. And I'm just going to bring down the variable. You don't do anything to the exponent when you're just combining coefficients. And this is plus 11. So my answer is going to be, I'm going to put this in order of the exponent. So it's going to be 5x squared, because that's the highest exponent of x. We like to write it in that order in algebra. Plus 7x plus 11. And that would be my answer of all of these terms combined. Okay? So if the stacking method is something that makes sense to you and helps you to sort these out, I highly recommend it. It does help you to see what you have in an orderly manner, and it's not all over the page. You're not trying to crisscross and go back and forth. It just stacks them up in neat little columns where you can see what you have. And if you cross them off after you put them in your columns, it makes it a lot easier to keep track of all of your terms and to know that you're not duplicating anything. And it makes it really easy to combine. And that's all we have for lesson 102. I will see you in lesson 103.